Hello, I'm Papia. In this problem, we will have to find the approximate area of a region. And the problem says that you have to use the midpoint rule with n equals 4. So you have to use 4 rectangles to approximate the area of the region that's bounded by the function that's tangent of x and x-axis inside the interval 0 to pi over 4. So let's first graph the function, understand the region, and then we will find the area of the rectangles. So it's tangent of x, that's the function. At 0, tangent of 0 is 0, so it starts at 0. And when you plug in pi over 4, you know the tangent of pi over 4 is 1. So tangent looks kind of like this, between 0 and pi over 4. So let's say this is pi over 4. And the value is 1. All right, we have to use 4 rectangles, so n is 4. Therefore, we can figure out how to partition this interval. So let's figure out the width of each rectangle, that's delta x, and that is b minus a over n, where a and b are given here in the interval. A is 0, b is pi over 4, and n is 4. So let's plug them in. So we will have pi over 4 minus 0 divided by 4, and that is pi over 16. Which means when you partition this interval 0 to pi over 4, each subinterval will have the length pi over 16. Okay, so let's roughly do that. All right. Now, what kind of rectangles are we using? That's important. See, we have to use midpoint rule, which means that the midpoint of each rectangle will be touching the curve. Not the left, not the right end point, but the midpoint. Okay, so in order to calculate the length of the rectangle, we need to know what is that midpoint, which means each of these subinterval, we know the length, but we have to figure out the midpoint of each of these subintervals. Okay, in order to do that, I always suggest let's write down these endpoints of the subinterval. So we have 0 as the first point, right? The next point, what is this x value? First one is 0. Look that the length of the subinterval is pi over 16. Therefore, this x value is pi over 16. So that's the next point. All right, what is the third point here? Each subinterval has the same length pi over 16. So the total length is 2 times pi over 16. So the next one will be 2 times pi over 16, which is same as pi over 8. Okay, so this one is pi over 8. The following one, of course, is 3 times pi over 16. So this one is 3 pi over 16. And the last one is 4 pi over 16, which is pi over 4. So that gave us each x value of the partition, right? Because we need them to figure out the midpoint of each subinterval. All right. If you want to see what the rectangles will look like, so let's draw them quickly. So we'll have 4 rectangles, right? N is 4. Remember, the midpoint will touch. So this is the first one. Say this is the midpoint. For the next one, the last one, so those are the rectangles. So 1, 2, 3, 4 rectangles. We have to find the area of each one and then add them, and that will give us the approximate area. Okay. So let's use a table to find all the lengths of the rectangles, the widths, and the areas. Okay, so we have 1, 2, 3, 4 rectangles. We are using the midpoints. So next we will figure out all the midpoints. Call them CI. Once we figured those midpoints, we can plug the midpoints in the function to get the length of each rectangle. So the length is just f of these midpoints. And finally, we'll find the area. Now notice area of a rectangle is length times width. Length is f of CI and width is the same, is pi over 16 or delta x. Okay, so start from the first rectangle. So the first rectangle, the main thing is we have to figure out the midpoint. Midpoint of which interval between 0 and pi over 16. So look here, 0 and pi over 16. Those are the endpoints. We have to find the midpoint. How do we do that? Well, 0 plus pi over 16 divided by 2. So that is pi over 32. That's the first midpoint. So for the second midpoint, we have to consider the next subinterval that's between pi over 16 and pi over 8. So here, between pi over 16 and pi over 8. How to find the midpoint? Well, same way as before. You add pi over 16 and pi over 8 and divide by 2. And that is 3 pi over 32. So you keep on and you get the next two midpoints. So for the next one, we will consider the endpoints pi over 8 and 3 pi over 16. So add pi over 8, 3 pi over 16 and divide by 2. So that is 5 pi over 32. And for the last one, you use 3 pi over 16 and pi over 4. So 3 pi over 16 plus pi over 4 divided by 2, that is 7 pi over 32. So we got all the midpoints. We have to find the lengths of each rectangle. And you can do that by plugging in the midpoint inside the function. So the first length is, function is tangent. So tangent of pi over 32. Second rectangle, the length is tangent of 3 pi over 32. Third, tangent of 5 pi over 32. The last one, tangent of 7 pi over 32. So these are the lengths. We know that each one of the rectangle have the same width, delta x. So you just multiply the length with delta x, which is pi over 16. So the area is tangent of pi over 32 times pi over 16, and so on for the rest. Second one, tangent 3 pi over 32 times pi over 16. Third one, tangent of 5 pi over 32 times pi over 16. And the fourth one, tangent 7 pi over 32 times pi over 16. So we have the areas of all four rectangles. Just have to add them and we get our approximate area. So the total area of the four rectangles, you add all four values in the last column, and look that pi over 16 is a common factor. Pull that out and you just add the lengths. So tangent of pi over 32 plus tangent 3 pi over 32 plus tangent 5 pi over 32 and plus tangent of 7 pi over 32. Okay, you use any graphing utility to plug in these values, and the approximate area of this region under the graph of tangent of x above x-axis between 0 and pi over 4 is approximately 0.345. That completes the problem. Thank you.